Hello everyone and welcome to our third online tutorial of the Google Pagespeed Race 2018. Today is a special series. Why? You will see new faces and we make it very easy. We'll see in a second. So last year, on the last tutorial, Lars and Daniel actually spoke about a few important optimization techniques, especially when it comes to caching and especially when it comes to advanced image optimization techniques like using WebP, stronger image compression. Today, we will actually focus on a big remaining topic. And this remaining topic will be render blocking scripts and optimizing the critical path. And for that, I actually got support. So my name is Martin. I work together with Lars of the Pagespeed Race. To make it very easy, as promised, we'll keep it easy with the names. I brought two more Martins today. There's Martin Schierle from Google. He's also a mobile solutions consultant at Google, and Martin Wagner from Bücher.de. But please introduce yourself to the audience.
Hello, I'm Martin. I'm working for Bücher.de as a web developer. We are a small developer team. We are 4 developers for the whole web shop. And the main part for me is all about the front end. So I'm doing the JavaScript and CSS and HTML stuff. When I came into the company in 2014, the first big project I had was building responsive templates. And we launched this responsive shop in 2015. And that's the shop which is currently live. So I brought you today a few examples how we improved our scoring and the critical rendering path. And some of these examples are, they're old. They're from 2015 for some of them. The last big performance improvement we did was at the beginning of 2017. And there we fixed the rendering blocking. And I will give you a few examples today. And I hope that I can help you for improving your scores.
Cool. Very good. So Martin Schierle, why are you here then?
So my name is Martin, as I already said. We make it easy today. I'm working for Google as a mobile solution consultant, which basically means I'm like a technical consultant to our biggest clients, advertisers out there, and trying to help them with the mobile side. So obviously speed is a big topic for us, right? We're all crazy about speed and having fast websites, snappy, responsive websites. And one important part of that is obviously the critical rendering path. So I very often go out and talk with people, look at their websites and see the critical rendering path is blocked and tell them to unblock it, make the page faster, right? Get pixels on the screen as fast as possible. For us, it's very easy often to look at it from the outside and tell people to make something better or fix it, but we know it's not easy. It's by far not easy, and that's why we are so happy to have somebody here to talk about like a real life case where they did do that, where they unblocked the critical rendering path and fixed the issues. So it's really great. Thank you again.
Yeah, we're delighted to have Martin Wagner from Bücher.de here because he actually scored very well in last year's Google Pagespeed Race. And he scored top 3 and made a big difference actually again on render blocking scripts, which is a big topic for all of us. Maybe before we deep dive into the topic itself, Martin Schierle, what do you say is actually the critical path all about?
So the critical rendering path is basically the set of resources a browser needs to load to get something painted on the screen. To get the first pixel, there's a set of JavaScript and CSS and potentially other stuff which needs to be loaded, right? So basically, the browser has to construct a render tree, which is part of the document object model, the DOM tree, the CSS tree. Basically, that stuff gets combined to the render tree. A lot of details, but basically, there's a set of resources which need to be loaded, normally JavaScript and CSS, to get something on the screen. Why is that important? So basically, until the first pixel comes on the screen, the page is basically empty. It's blank, right? It's a blank browser screen. And this is where users are most likely to jump off, right? So as Google, we see a big correlation between users jumping off, page abandonment and bounce rate, and that kind of period of the blank screen. So basically, you want to get pixels as fast as possible on the screen to reduce your bounce rate and to increase your conversions. This is the goal. This is the idea behind it. As long as the screen is blank, the user will not know, is the page still loading? Isn't it loading? Is something coming up? Is it broken? Did my internet go away? So try to get that period of time as small as possible. Reduce the blank screen, unblock the critical rendering path, and get pixels on the screen as fast as possible.
So what do you usually say that's an issue we are facing or something which is important for the first load or for the second load? Or
So that's mainly a first load thing, but obviously it depends on if those critical resources are caching or not, right? So in general, the the critical rendering path is characterized by a few things, right? What resources are in there, how many, how big are they, obviously, right? How much of that is used, so you don't want to block the rendering path with a huge file which is never used, or like to 99% unused, obviously. Like the worst thing you can do is block the critical rendering path with a large file which does not cache and is needed every time and reloaded every time. So basically, normally it affects most the first load. If the stuff caches well, it's only the first load. If things don't cache well, it might affect further loads as well. The other thing is, especially coming from a perspective like a Google point of view, if you think about search traffic, social traffic, campaign traffic, that's all an uncached first load. So this is basically what hits the critical rendering path. So if you pay money to get somebody to your page, you do not want to give them the worst possible experience. You want to optimize for the first load, and you want to optimize the critical rendering path.
So maybe let's start from very early. How do I actually see if I got a problem or not? Maybe Martin from Bücher.de, how did you actually see that?
Yeah, I can tell it to you, and we can also share my screen. One of the first identifier is for sure Google Pagespeed Insight. The website we had in the beginning of 2017 isn't online anymore, but I have a few parameters that I can show you the page, how the page looked, especially for the rendering path.
Cool.
And that's what we do now.
Cool, let's have a look.
That's the page Speed Insight with our critical, non-critical URL. And well, yeah, there you see the scoring. It's a scoring of 67 of 100. And we see the optimizations we could do. And the biggest one is the eliminate rendering blocking with CSS. And there we see we have the CSS resources which block the rendering. The other point, leverage browser caching isn't really an issue. It's because it's third-party stuff like Google Analytics or the Facebook pixel. So that's the first identifier. And I use webpagetest.org, and I made a webpagetest.org for this non-critical variant. And the next identifier is, there we see the first byte was sent or received after 1.5 seconds. And the rendering starts after 3.3 seconds. So it took more than 1.5 seconds until the rendering could start. And that's the main issue. If you go to the film strip of this web page test, we will see it. Until 3 seconds, we had a big white page. And for the customer, this test was made with a 3G network. So the customer didn't see anything in 3 seconds. He didn't know, like Martin noticed, is my internet broken or is the website broken? We don't know.
And it's also important to mention why we should do that always on 3G. So basically, if you look at a country like Germany, there might be a lot of people on 4G or Wi-Fi. But basically, for mobile phone, you always have to assume, like, not necessarily the worst possible connection, but you have to assume a bad connection, basically. Even on Wi-Fi, even on 4G, the connection might be bad. For Wi-Fi, there might be walls between you and the router. You might be in the basement or somewhere under the roof, right, far away from the router. For like mobile traffic, carrier traffic, there might be a lot of people in one cell phone tower. If you're like in a soccer stadium, if there's a traffic jam, whatever, right? If you're somewhere in the subway, you always have to assume the connection might be bad. You should always optimize for at least the 3G connection.
Yeah. Also, if you're in a bus or in a train, you lost the connection, and
exactly,
that's the problem.
And that's also why people are very curious about that blank page state, because for mobile, you can never be sure if the connection is really there, right? It's Wi-Fi. Yeah. You can't rely on it. So basically, if the page stays blank, it might just be that your connection just died. You're on the train, it stays blank. Maybe it died. User goes away, never comes back, right? So that's what happens.
Yeah, right. And that's the point. And we also have the network tab at the webpagetest.org. And let's have a closer look to our website. And there we see we have a top banner, and we have 3 products which are teasered. And let's have a look at the network tab. And there we see that the 3 product images were loaded at position 18 to 20. So we load a lot of other stuff in between, and that's the point. That's not necessary. We should focus on the above the fold content. We should focus on the stuff we need earlier. And yeah, that's what we did.
It's important also to say that web page test very nicely highlights with the green line also where the first render is and the other important loading states. So you can easily see what resources are loaded between first start of loading and basically the first paint.
And I also like to use it because if I develop at my computer at the work, the problem is I have an internal network to the web server, and it's much faster than over a DSL or something else. So if I check with the Chrome DevTools at my office, the website is much faster than it really is. And with webpagetest.org, I can simulate that mobile connection from anywhere in the world, from Germany or also from Austria or USA or wherever. And that's a great point.
Yeah, that's also a culprit that a lot of developers fall into. They test like on their machines, on their Wi-Fi, and on their internet connection. They probably with a full cache, right? And then they are like, oh, my page is fast, but very often it isn't. It's not the experience your users have, right? You should always test in a similar setup as the users have, right? You should test on bad connections, on phones with bad CPUs, with a clean cache, right? Because that's what your users see. And very often, especially the first-time users see that, right? The ones you want to convert it to like brand users.
So you already seen Pagespeed Insights and also webpages.org. Have you used any other tools in that?
We're also using Lighthouse since around 1 year. And we can also use it with the webpagetest.org. We can also check the Lighthouse. So that's the Lighthouse reporting for the non-critical website we had. And there we see exactly the same. The first meaningful paint is after 3.4 seconds. It's similar to the webpagetest.org. And Lighthouse is great because it combines a lot of dev tools we used before. We see the performance for sure. We also see the progressive web app. We see accessibility, best practice, and also since a few weeks SEO topic. And that's pretty cool because it's all combined in one tool, and you can use it with your Chrome normally with the Audit tab.
So for the Pagespeed Race, we use our own instance for Lighthouse. Martin Schiller, maybe you would want to discuss something why it would have benefits on using it via webpagetest.org.
So personally, I like really using it via webpagetest.org. One reason is that you always get like the newest versions, especially if you select like a Chrome Canary in webpage test, right? Then you can also run it from different geos, which you can't easily do on your own machine, right? Then another advantage is that it's not like influenced by like Chrome extensions on your local machine, or in general, whatever on your local machine might track it down or influence it, right? This is a clear lab setup. This is easy to repeat, easy to compare between runs, also between large amounts of times. So this is really a nice way to run Lighthouse, and you get the combined view with web page test. So you get a ton of metrics, potentially more than you will ever look at, which is amazing. And you can always go back in time, look at the same URL again, see the same Lighthouse report again. So this is really amazing. And also what Martin mentioned, you also get a lot of other reports like SEO and stuff. Basically, Lighthouse is supposed to be like Google's combined view towards the website, what we think of it.
So maybe let's have a look into this report.
Yeah, well, we see also the opportunities that we have rendering blocking style sheets. There we see the 2 style sheets. And for that example, we are seeing 2 style sheets. The problem is today we have a critical CSS, and it's also minified. So that's the reason why we see 2 CSS files. At the beginning of 2017, we had just one file. So that's not a reality, what we're seeing here. Yeah.
And it's also nice to see directly in here, you get also like the estimated time improvement if you would optimize that, how much performance gain you would get from that, right? So it's obviously an estimate. It might not be accurate, but it's still interesting to see. And it's also interesting to see here that you have like 1.6 seconds for like just 28 kilobytes. And if you go back to web page test, it's also interesting to see why you see all that server overhead for like the connection, the DNS lookup, the SSL handshake. So even if you have, or especially if you have small files, it's really annoying to pay the huge penalty for the request response cycle, the network overhead, just to get a few kilobytes of data, and it delays your page really much.
So you already mentioned a few topics. Are there any quick wins which you would usually see?
So it obviously depends what is blocking your critical rendering path. As said before, whatever blocks your critical rendering path, at least make sure that it caches very, very well, right? Because if you have to take the hit for whatever reason, please only take it for the first load, right? So that's one thing. Then the other thing is some easy quick wins, just like minify the files, obfuscate them, strip out comments, white space, right? You don't want to delay the user and let him wait for getting white space over the wire, basically, right? You do not want to do that. Getting third parties out of the way makes a lot of sense. Third parties should not block your critical rendering path. If possible, by any means, remove third parties out of the critical rendering path. It also makes you very dependent of the third party. If they are down, if you get timeouts querying them, it drags down your complete page. You might kill your complete page by an outage of the third party. You do not want to have that kind of dependency, obviously, right? What you can also do is if you have like several CSS or JS files which are blocking the critical rendering path and you really feel like you need all of them, please at least concatenate them if you're on HTTP1 or try to switch to HTTP2 so they don't have like the additional network overhead for each request and response cycle. So there are like a few things which you can do and which you definitely should do, right? But very often it's like the more invasive or disruptive things to which are needed to completely unblock the critical rendering path. In general, from a Google perspective, we would say that you should get as much as possible with the first request response cycle and have a clear critical rendering path, which is not trivial at all. But Martin can tell us a little bit more about what you can do to get towards that direction.
Yeah, sure. One very important point is for sure the cleanup. I recognize that we're using a lot of libraries for as polyfill or something else. For example, we had a library for the fast click delay on smartphones. On the smartphones, you had a touch delay of 300 milliseconds, and therefore we had a JavaScript library, and we need this library in 2015. Today we don't need this, so we can remove it, and that's what we should do. We should always look at our libraries and think about, do we really need this library? We're also using a CSS framework, Bootstrap, and Bootstrap is great. It's had a lot of predefined classes, but we don't need all of them. For example, at Bücher.de, we don't need the pagination or the breadcrumb, so we can skip it out. And that's what we did. We did a cleanup of Bootstrap, and it saved 50 kilobyte, which was minified, and that's really a lot. It's around 50%, which we would save. And yeah, that's what you should do. You should do a cleanup.
I think that's a pattern we see very often, that there's a lot of stuff loaded which maybe is largely unused or not used anymore, right? Legacy stuff. It was added at some point because it made sense and then never removed later on after the reason for the add-on was gone, right? Then you import libraries of which you only use like 10%, but the rest is still loaded, is blocking your page and carried along. So just cleaning out unused stuff, that already helps a lot very often.
But everyone knows like cleaning up takes time. How do you prioritize this topic in particular for your workflow when you optimized your page?
Yeah, well, it's a good question. The point is you need time for that, and you need the freedom for doing this. Normally, we had the problem that we get an IT project, and it's we have to do this in around, for example, let's say in 2 weeks, and we don't have the time for fixing all the stuff, doing it right, because we would normally need 3 weeks for doing this, and that's a big problem, and that's a problem I also had at Bücher.de. But I took the time I needed for cleanups and for improving the scores, and after I was able to share the first results, it's very easy today. If I tell my boss I have to clean up something for the performance, I can do it. I get the time. So that's the biggest problem.
So maybe show us how you started.
Yeah,
you were so successful.
I can show you a good example about the a third-party library. Let's talk about jQuery. I'm pretty sure it's common. We can. It's already shared.
Yeah, we should see a screen.
So I think that is very common. So we have a synchrone script tag to jQuery. We include an image. There's a headline, and then we use JavaScript for changing the color. Okay, that's just an example. Normally we would use CSS for changing the color, but for demonstrating the jQuery delay, I used that one. So If you now go to the script, so we see everything is all right. So let's throttle the network to a 3G network, then we would see a difference. So we will kill the body. So if you now reload the website, we see in the network tab that, okay, let's take the slower variant. That's was too fast for now. So now we see that we have a wide screen. The image is already loaded, and now jQuery is loading. And after jQuery was loaded completely, then we saw the content. But the image was already loaded. And that's the main issue, because we used a synchron script tag of jQuery. And I will show you how we could use the asynchron variant. And that's an example we had in our old responsive web shop, because in the past we had a lot of inline JavaScript stuff based on jQuery. And when I built a responsive template, I didn't have enough time for refactoring all the old code. And I want to serve the jQuery library asynchron. So therefore, I needed a solution. And it's a very easy solution. I just wrote a small jQuery asynchron loader. I'm sure there are a few of GitHub or somewhere else. I wrote it by myself. It's not a big problem. And the main point is we have a queue. And we build the document ready function. So every time the document ready function is triggered and jQuery isn't loaded, we pass the argument of the document ready function to the queue. And when jQuery is loaded, then we can trigger the whole queue, and that's what I do. So therefore, I need a timer, and I need a function which checks if jQuery is accessible or not. And at the end, that's the main part. So I define the dollar in the window jQuery with my own defined document ready function. And then I set the interval of 25 milliseconds. And every 25 milliseconds, I will check if jQuery is loaded. So the first check is jQuery loaded? No, it's not. So we can skip this. We can wait until the next 25 milliseconds. If it is loaded, then I can clear the timer, because I want to initialize my code only once, not more than once. And then I redefined the jQuery document ready function, and there I triggered all the stuff from the queue. So that's what I built. So let's take all of this code, use the asynchron. And we name it also asynchron, that we can see the difference. There's a possibility to add an asynchron attribute to a HTML script tag. So now the browser knows that the script we are referring is asynchron, so he can continue rendering. So now let's take a look what happens to our script. And there we see the text is much earlier visible. There's the image is visible. jQuery is still loading, but the text color didn't change. This didn't change because dollar is not defined. That's the problem with the asynchron jQuery. At the moment we're using the script tag, jQuery is not accessible, so it didn't work. So the question is, what could we do? We could do a really bad part, and I will show you this just as an example. Don't use it in a productive environment. We could use the set timeout function we have in JavaScript. So let's say we will wait around 5 seconds should be enough for doing this, and just see what happens. Therefore, I will take this faster switchy. So let's take a look what now happens. Okay, jQuery is loaded, and the color also changed. So we don't have the problem that dollar is not defined, but the problem is we have a fixed timeout of 5 seconds. So loading jQuery depends on the network connection. With a 3-tree network, 5 seconds will be enough. But what about an edge network? So this is not really a good practice. So I introduced you already our jQuery loader, and so let's take that one to see what happens. I just will inline this. I have a build script which inlines me this file. That's what I'm doing here. Yes. And now I wrap it with a document ready function. Let's just quick check if the inlining works correctly. Yep, it works. So if you now reload the website, you see, okay, the logo is there, and until jQuery was finished, the color changed. And now let's take a closer look to both variants, just as an example. And there we see the left one is the sync, and the right one is the asynchron. And there we see it's much faster. The end, it took the same time for changing the color of the hello world because we had the dependency of jQuery. But the user sees the interaction much earlier. And that's the point. The jQuery library is just an example for now. You can do this with any other framework too. So that's just as example.
Yeah, I think that's an important message here. Like, if you're dependent on libraries and JavaScript scripts, a lot of the stuff can be loaded asynchronously, right, or can be deferred. So especially third-party stuff very often has the option to be async, right? At least it should be like that. And even if you encounter something which seems like it isn't async by nature, you might find a way to defer it yourself, or maybe just break out what you need right now, defer the rest. So very often you can find a solution if you search a little bit for it.
Maybe one more question regarding the application of your historic page and now. So if you would like to rebuild the whole page now, would you still rely on jQuery, or would you move on?
If I would relaunch the website today, I wouldn't use the dependency of jQuery. Today we are having document query selector with native JavaScript. We're also having ECMAScript promises, and today we wouldn't need jQuery anymore. That's because of the historic web shop. And in 2015, it was different. So today I wouldn't use it for sure.
It's always easy to look back.
Yeah, sure.
Maybe onto another topic. When we look into our pages, which are part of the participant field, we see a lot of images being used. And also on your page, we see a lot of images. Is there a particular hint or trick you would have, which you would say you could share, how you proceed with images?
Yeah, for sure. We're having a lazy loader for images, so we load the images only if we need them. So if I go to our website and
maybe let's look again on your screen.
Yeah, sure. Yes. Let's take the images and let's clear it. So if I go to the slider and go to the next page, then I load the images which are needed. Also, when I scroll down, then I load the images which are needed. So we're using a lazy loader, and the problem is we have a custom lazy loader for our environment, and the lazy loader is included in our bundled JavaScript file, and it's a huge JavaScript file. So for the critical rendering, it is too late. So we needed a solution for including a subset of the image lazy loading inline, and that's exactly what we did. I can show you this with that example. If you inspect one of our images, there we see that we have two images. We have the HTML5 data attributes, data source and data source K. For smartphones, we deliver smaller images than for desktop. That's because of the loading performance. And when we built our webshop in 2015, it was the best solution we had. Today, we could think about source set and all the other stuff, but it wasn't common usable in 2015. So the point is, we know that the first slider could be potential inside the above default content. So for the first slider, we are doing exclusion. The first slider has an inline script tag, which also can load the images. So it's a subset of our lazy loader. The problem is our whole lazy loader is too big. The whole lazy loader detects the scrolling, and it's had a defined config when he should preload the images, and that's a lot too much for inlining it. So the best solution we had is just take a subset we really need, and that's inlined. So
yeah, but that's in fact a great pattern, right? You break out what you really need, inline this, right, and don't block the critical rendering path of the rest. You fill the rest, only break out what you really need and inline this. So this is a great pattern.
What else is interesting, and a common pattern across the pages, which we've seen in the Google Pagespeed Race, is that you use a carousel or image slider.
Yes, that's a really great point we have, and we had a lot of trouble with this carousel with the above default content. The problem is, if we look at our HTML, you see that most of the LE text isn't built. So we build the HTML elements when we need them. So if I now toggle in, I should use the right page. With JavaScript included, then there will be a toggle. But the code is still the same. There we see that that element didn't exist, and if I go to the next page, then the element is built. And that's what we did since 2015. We built all the slider content dynamically. The problem is our asynchronous JavaScript, so it's too late for the first content and for the above default content. So therefore, we decided that we will serve the first 5 elements for the first slider in line with our server. So we have a server rendering for that elements, and also the client rendering with JavaScript. And yeah, well, we decided to use 5 because of mobile. For a desktop, the problem is 1 is missing. We need 6. But for the smartphones, we don't want to serve 6. So it's a part of a compromise. And we think the customers which have a desktop connection would have a faster internet connection than a smartphone. So that's a compromise we had.
I think server-side rendering is in general a good idea to get stuff on the screen very quickly. If it directly comes with the first initial HTML response, then it's the quickest way to get something on the screen, obviously.
Cool. So we looked into images. Maybe focus on, because we also looked into JavaScript, now how images are applied. Maybe let's focus on the big one. What is remaining?
So CSS, obviously, that's the one which is missing. So I mean, for CSS, there are several ways, right? So basically, you can try to get the critical CSS extracted automatically and inline in some way. You can like mark it manually and break it out in some way. What did you guys try?
We tried both ways. And at the end of the day, we decided to define the critical CSS by ourselves. In 2016, I tried the first time an automatismus for building critical CSS with CLE command. And the result was pretty bad. I received a critical CSS was around 60 kilobyte, and that's way too lot. Yeah. Last week, I gave them a second chance, and I tried it with our Bücher.de shop, and the results are pretty cool. So let's start with the automatismus.
So let's look back on your screen and have a look.
There, we will have. I took 2 packages. I took the critical and the critical CSS. Both are working pretty well, and I just had one build script, and yeah, well, that's all I need. I run the command. I give the command the URL which I want, and I give the command where he should put the critical CSS. And I will change the directory. Okay, so I just have to type the command, wait a few seconds, and after that, the critical CSS is automatically generated. And that's pretty cool. If I look there, I see the CSS is generated. It has 25 kilobyte. That's OK. I can give you an example how this look at our shop. That one is the generated one. And it looks pretty well. So yeah, well, we're seeing icons are missing, but that's based on the icon font we're using. Also, the content banner are not perfect, but they are not in the above the fold content, so that's OK. The big problem is you have to generate the critical CSS for every subpage you have. If I now change to a category page we're having, for example, there, and I add the critical parameter, there we see the breadcrumb is missing. Also, the stuff here didn't look pretty cool. Also, the content besides the product is not good. And that's a problem. You have to generate the critical CSS for every subset of page you have. And also the problem is the tool generates the critical CSS, but you're also serving this critical CSS with your main CSS. So currently, we're serving the CSS files twice, and that's not needed. And the last point is we have a critical CSS currently, which is defined by ourselves, and it has around 24 kilobyte for all the page types we have. So it's not that heavy than the automatic generated one. And one example is, for example, the automatic one took the red color of the sail. We didn't, because for me, the red color isn't that important. Important for me is that the layout didn't jump. That's much more important. So the developer could decide what is really necessary and what not. So I can give you an example how we solved this with our SaaS environment. So I'll go to the next project. We have component-based SAS files. So we have one SAS file for the header and one for the footer, one for the product, whatever. And I don't want to split my SAS files. So if I look to this header file, the logo may be important in the navigation also. The H over for the navigation is not important for the critical rendering because it occurs on the first interaction. So I want to move that one to the non-critical and the first two to the critical. So, and I don't want to split my files. And therefore, as an easy solution, I wrote a small mixin, which I can use. It's the non-critical and it's the critical mixin. And I'm using a local variable which can switch between critical and not critical. So what I'm doing is I take my style SAS file, and then I set the critical to false. Then inside the header file, I'm going there and tell the code include as non. Okay, well, that's wrong. That's the critical part. That's it. And then I took the second one, which is not critical. And if I now look to my generated SAS file, I will see that the normal style CSS has only the H over. And then I take the whole SAS file, copy that one to my critical, and that time I tell the SAS compiler critical is true. So now I can look at the critical CSS, and there I see I just have the logo in the navigation without the H over. And that's how we handled that in our Bücher.de environment. And I also, well, we're using SAS. In the past, also less was a good practice. So I made the same example with a similar mixin. It's just a bit different code. and that's also working, and that's the same example. And the problem is now you have to go through all your CSS definitions to all your SAS files. That's time you have to spend. There's no way out.
Yeah, so it's a little bit more manual, basically, but it gives you far more control. And you can also make judgment calls as with the sales item and the hovers and whatnot. So this is also like pretty cool. And then the end goal is basically, obviously, inline the critical stuff, right? So that it's not blocking the critical rendering path and delay the rest.
Yeah, for sure. And the critical file should be as small as possible.
Yeah.
So you shouldn't inline 60 kilobyte. That's way too much because you're serving it with every request. That's the problem.
Right. So we learned a lot until now. We looked at JavaScript, CSS, how images are then positioned in the place. Is there anything else I can do? When I've looked at that, I'm all done.
Yeah, well, most of the part is done. Yes. We can take a closer look at the scoring, what happens until now. So maybe that would be.
Well, maybe one sentence about fonts. Did you have to do anything to do about fonts?
Yeah, fonts is an interesting topic. Yeah. We have. We were having web fonts for our main headline.
Okay, look again at the screen, and then we see the headline.
Sure. And we are serving the fonts only for desktop environments. We don't serve the fonts for smartphones. For smartphones, we use the native system fonts because we won't download a lot of kilobyte just because of the headline font. And that's not
it also delays the rendering, obviously. I mean, you can bring in a standard font, but then you have a font flash. You can wait for the real font, but then you make the user wait. So web fonts are not always necessarily great.
Yep, that's the point. They're reloading the Roboto font at our environment, and we toggle to our smartphone environment. We are just serving an icon font. So an icon font is also an interesting topic. In the past, we used only the icon font. The problem is the icon font is served with our main CSS file. It's pretty late in the rendering. So therefore, we changed the critical icons to be inline SVG. And we're still having the icon fonts for the icon, which are not that important. For example, the Tolino icon or the voucher icon. But the main icons we were having, they were served inline. So that's the big trick for the critical rendering.
That's a good idea. We can also mention that there's a nice font loading API, which gives you a little bit more control if using web fonts, like how their behavior is with blocking and timeouts and things like that. But always keep an eye out for web fonts, because it's not nice for the user if he has to wait forever just until the font kicks in.
Good point. We're using the API or the library for the web fonts. And in the past, we served that library because we have a bundled JavaScript file for our clients. We served it also for the smartphones, and the smartphones never loaded a web font. And that's part of the topics you have to think about if you bundle one big file. Do you need the libraries really for all devices? And our solution was that we built a subset of JavaScript which we serve only for desktops. And that includes the web font loader. So for smartphones today, we don't serve the loader.
Yeah.
Cool. Very smart. So today we learned a lot, I have to say. We addressed some big issues. We hope everyone enjoyed the online tutorial.
You have still not the compare and the...
Oh, true.
Sure.
Good one.
I can tell you, yeah, well, we talked about that we improved the score, but do we really have a good score? So I can share our actual score.
Now comes the big moment. We can see.
Oh, I hope it's better than 80. Yeah, that's our current score.
All green.
We have 99 of 100, and the desktop is also 97 of 100. And yeah, well, the improvements we have is still the browser caching of analytics. Maybe we can address this at Google. And there's also one tracking pixel, which is not optimized. So the score we have is really great. There's not many room for improvements. And I can also show you the current web page test we have. And compared to the first one I showed you a few minutes ago, the rendering started at 3.3 seconds, and was the critical variant. The rendering starts at 1.8 seconds, so that's 1.5 seconds faster, and that's really much time. And we see it at the film strip that now the rendering is able to start after 2 seconds. Let's just have a small short look to the network tab. There we see that the product images, the 3 product images, are now at position 4 to 6, much better than on position 20. And we can compare the 2 film strips, and that's a big difference we see. So at the old variant, it took 3.5 seconds until the rendering starts. And now the rendering starts after 2 seconds. After 3.5 seconds, we have already 52%. Compared to the 22 we had before. So
that's a huge improvement.
And that's a huge improvement.
And you will definitely see that in bounce rates and abortion rates.
We had when we launched the critical CSS, we had an A/B test, and we recognized it in the conversion, especially for the mobile connections. For desktop, it wasn't the big difference, but for the mobile connections, we saw a big improvement in the conversion. Yeah.
So
very nice.
We see a lot of your hints. Before we close off, I think everyone is waiting for some secrets which you haven't told us. So maybe let's do a little circle of what you would say are some hints you would give for the participants who have a few weeks left to optimize their pages before the race officially closes. So maybe you would have some secrets to tell which you haven't told, because you already implemented, you already showcased a lot of the implementations also on GitHub, which we will share in the aftermath of this one, but maybe you tell us some secrets.
Yeah, well, the point is there's not the big secret. It's a lot of work you have to do, and we're all learning from each other. So if you see something in our shop which you think you're doing that better, you're welcome to share your ideas with me. So that's the last message I want to place. So we're all living together. So let's improve it together.
Right. Thanks, Martin, from you.
So really, it was amazing to see all that from your side. Basically, what we've seen today, I think is really important. So basically, keep in mind, optimize the critical rendering path, use the tools to find out what is blocking you, make sure it caches well, remove unused stuff, try to defer whatever you can, make stuff async, break out what's really needed and inline that, and defer the rest. Just make everything you can to unblock the critical rendering path. It's really important. Also look out for the other topics we're also covering or did cover, like the image optimization is in general really important, right? Like a lot of data which is transmitted nowadays is just images, obviously, which could be compressed much better. Make sure to lazy load whatever you can lazy load. Lazy loading images today with intersection observer is really easy. Make sure you do that. Keep a lookout on Lighthouse. This is the one-stop show from Google to care about.
Very good. So we hope you found this online tutorial very helpful. Addressing one of the bigger issues we can find on website optimizations. We wish you all the best for the next few weeks of optimizations, and hope you have a lot of success. Till then, see you soon, and thanks, Martin.
Thank you.
Thanks. Yeah.
Bye, guys.
Bye.
Bye.